Hey students, today we will be talking about forces in motion. Gravity is a force that always attracts or pulls objects towards each other without direct contact or impact. Gravity affects everyone. Isaac Newton discovered gravity when an apple fell out of a tree and hit him in the head. Take this ball for example. No matter how hard I throw it up, it's always going to come back down. Now on to friction. Friction is the force that occurs when one object rubs against another object. The two factors that determine friction are the kinds of surface and the forces pressing the surfaces together. Friction also is a force that acts as resisting sliding between two surfaces that are touching. It can slow down or stop the motion of a force, like skating. If you skate on ice, you can go pretty far, but if you try to skate on the asphalt, you're not going very far at all. Now, on to force. If an object is in motion and more force is applied to it, the object will begin moving faster. Take this sack of peanuts, for example. If I just throw them up, they're not going to go very fast. If I throw them up and hit them, they're going to go way faster. Now, that is done. If an object must be slowed down quickly, the force applied to the object must be greater than what is needed for a gradual slowdown. Take example. If this rock and this little gumball thing are thrown up, this I can easily stop. The rock, it's harder to stop. Now, we're moving on to mass. If a heavier, more massive object is in the motion, more force must be applied to get the object moving faster. If the same force is applied to two objects, the object with smaller mass will change speeds more quickly. Take, for example, the rock and the ruler. I can hit this thing, it's less mass, and it will go pretty far. I can hit the rock, and it's not going anywhere. Now we move on to balance forces. Balance forces will cause no change in the motion of the object. Balance forces are acting on an object in opposing directions or equal strength. Do not cause change in speed or magnitude or direction of the moving objects. Moving objects will not start moving if acted upon by balance forces. For example, take that rock. I have two volunteers that are going to push it and with the same force and see if the rock moves. See, the rock will not move. Unbalanced forces are not equal, and they will always cause a change in motion of an object to change the speed and or direction of the moving object. When two unbalanced forces are exerted in opposite directions, the combined force is different between the two forces, or if in a tug-of-war team, one team pulls harder than the other. The resulting action, the net force, will always be greater. The rope will change motion in the direction of the force with the greater strength or magnitude. The net force is how you measure unbalanced forces. Take these two people here, for example. They're going to pull the ruler. The one with the stronger net force will pull the other one onto the blue thing. Go. That's it, folks.